Number 6 says that in an A-frame house, the roof extends to the ground level. If each side of the roof meets the ground at 66-degree angle, what will be the measure of the angle where the two sides of the roof meet? Okay, so that means if it makes a 66-degree angle with the ground, this is, by definition, an isosceles triangle, making these sides congruent. Not that that's important to solve the problem, but I hope you would recognize that if the base angles are congruent, then the opposite sides are also congruent. So to find this angle here, we're just going to do 66, add these two together, so 132, and of course subtract from 180, and we get 48 degrees is the angle at the top where the two sides of the roof meet. Number 7. Now I don't want you to panic about the proof because this is information that you already know, okay? So what we're given here is that AB is congruent to AD, and that is marked here and here. And that BC is congruent to DC. And of course, those sides are marked here. We want to prove that angle ABC, so ABC, is congruent to ADC. Okay. Now, remember when we were identifying our triangle theorems? That's essentially what we're trying to prove here, okay? And remember when I said any side that a triangle shared can be considered congruent, okay? So, based on that piece of information, we can prove that both these smaller triangles are congruent by side, 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 okay? You're told that 2 of the sides are congruent and the third side they share. So we can assume, obviously, anything is congruent to itself. So, which statement justifies that these 2 smaller triangles are congruent? It is side, side, side. Now, this is a similar question. Okay. Same information. Now we were already determined that this is side, side, side. Okay, so this is a continuation of the previous proof. The question, what it's asking is, okay, so how are we proving, if the 2 triangles are together, how do we prove that the 2 remaining angles are also congruent? If you remember what we discussed about proving triangles, we said that the 4 special congruence theorems, side, 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 angle, side, angle, and angle, angle, side, were all used because they maintain the congruence of all the other remaining pieces of the triangle. Okay? So what that means is once we've proven that the 2 triangles are congruent, we can assume that all the other pieces are also congruent. And that just has a special name called corresponding parts of congruent triangles are congruent. That's all that is. It's what we reviewed previously. It's just fancy way. You might also see it in your textbook as it's abbreviated CPCTC. Okay, congruent parts of congruent triangles are congruent. Okay? That's the whole point of studying the four triangle congruence theorems. By having those three pieces, it was proven that all the other corresponding parts matched. So that's what we call that. Okay. Number 9, which additional statements are required to prove that triangle ABC is congruent to LKM using SAS if angle L is congruent to angle A? Okay, so what you don't have here is a picture. So we need to draw a picture. I think that would help. Okay, so we've got, all right, so we got ABC, and we have LKM. Okay. We're told that angle L is congruent to angle A. Now, if we need side angle side, we would need AB to be congruent to LK, and we'd also need AC to be congruent to LM. So AB congruent to LK and AC congruent to LM. There you go. And that is how we get side angle side.